Now as we're getting into the problem set for related rates, we're going to use, looks like it's a circle. It says if A is the area of a circle, find dA dt in terms of dR dt. Well, what the heck does all of that mean? Let's look at the rest. It says suppose oil spills from a ruptured tanker. Here's our tanker. Oil is spreading. The radius is going to be our dR, and this is going to be our starting radius. So of course, as circles increase in size, their area increases different depending on how big it is, right? So we're going to need to know some specifics. Looks like they'll give it to us too. They say if the radius of the oil spill increases, so that would be a change in radius and a change in time at 1 meter per second, how fast is the area of the spill increasing when the radius is 30? So they tell us the radius is 30. Well, what do we know? We know the area for a circle is pi r squared. So I can do dA dr, because this formula only has a radius in it, is going to be 2 pi r. And what are they asking for? How fast is the area of the spill increasing? So that would be dA dt is what they're asking for. So how would I get to that? Well, dA dt, if I start with dA dr, I'm going to need to be able to cancel out this dr, so I'll put a dr on top, and I'm going to need to replace it with a dt, so I'll have that on bottom. And this is where the related rates part comes in. This is what they mean by related rates. If you take these different derivatives, you can use them to figure each other out. We actually know some of this, right? Because here's dr dt, we'll put that right in there. And here's dA dr, I'm going to put that right in there. And they're asking us for the change in area over the change in time. So we can say, hey, dA dt is equal to 2 pi, and the radius is 30, and dr dt is 1. So we get 60 pi. That's going to be like 188.5 maybe square meters per second. That's the answer to this question. So all we need to do is remember that we're producing this kind of, it's just basically fractions and canceling, right? I know it's derivatives and I know it's scary, but it's about taking the formula you know, taking the correct derivative and labeling it correctly, and comparing it with the given data and just plugging it into the equation. We'll get more practice in the next problem.